Alrighty, so I wasn't planning on doing another assignment for geometry. As it is right now, we've just taken the 1.2 test. The plan was taking advantage of the quick day on Wednesday, just kind of go over the 1.2 test, and then do a direct review on Thursday for the final test 1.3 on Friday. However, as I started grading the exams, as I started going through the tests, I kind of noticed a pattern, kind of noticed a repeating pattern. The people that got DV and DV plus were ones that kept making the same mistakes, the same exact mistakes every single time, which makes sense, obviously. Normally you would expect more of a spread of mistakes, like they'd be wrong about, some people would be wrong about this, some people would be wrong about this. No, these are the mistakes that are made every single time. So we've either got the tests where, like, it's a perfect score, maybe one or two things wrong, so it's like SC, maybe SC plus. Then you got the tests that are DV, DV plus, because the same mistakes are made. So because of that, that's where lesson 1.7 came from. We are going to go through each of these. I hate to say mistakes, but we're going to go through all of these problems one by one. I'm probably going to assign this as an assignment on Thursday in addition to the review. But we're just going to go through each of these one at a time, and hopefully you'll pick up the same pattern I did when we were talking about what went wrong with whom. All right, so I've already got figure A drawn up, and we're going to be using figure A for the first 8 problems. So we've got all right, drawing this simple, how can we find 8 problems? We can find 8 problems. All right, so what is another name for line A? So what is another name for line A? We've got line A right here. It's the one going diagonally up and down. It's the one going diagonally up and down. It's the one going towards the curly QX. When you're naming line A, or when you're trying to name a line, you can't get away with just calling it line A. Additionally, the A, the curly QA up here, the cursive A, is not a point. What it is a label that makes labeling lines easier. But you don't get to do that. The only time you get to call a line by a cursive letter is if you're doing a construction on the assessment, and the assessment says draw lines A and B such that so on and so forth. That's the only time you will ever get to call a line A. And again, A is not a point. It is absolutely not a point. So if you want to list A as one of the points for your line, it's not a point, and it will be wrong if you list it as a point. So let's get back to what is another name for line A. In order to name a line, you need 2 points. Only 2 points. If you have 1 point, you're almost there, not quite. If you have 3 points, too much. You've named a plane, except it's not a plane. You need exactly 2 points. Just 2 points. So I've got options. I've got a couple of different options I can do. I've got 3 points on the line. All I need to do is pick 2 of them. Any 2. It doesn't matter which 2 I pick. I can only pick 2 in order to name the line. So this, I'm just going to say KG. And remember, when you're naming a line, you have to include the double arrows above the line definition. I will say, even though I'm hitting the double arrow thing again, most folks actually did really well with the double arrow line, so I'm glad everyone's paying attention to that. Please pay attention to the rest of the assignment, of this assignment. All right, number 2, what is another name for B? So we're looking at this line here. Again, B is not a point. You do not get to call it line B. I've got 3 points here. You must pick 2 points from any of these 3 in order to name the line. If you say line H, not enough. If you say line J, that's not enough either. If you were, however, to say line HJ, then we're set. That is exactly the right kind of answer that I'm looking for. It is 2 points that are on the same line. That is how you name a line, or that is how you give another name for a line. If you wrote, for example, HGJ, no, that is not the name for a line. That is not how you name a line. You name a line with 2 points. HG, HJ, GJ, or any other combination of those 2 points. That is how you name a line. All right, what is another name for plane X? This is plane X. In order to name a plane, you need 3 non-collinear points. Gone over this several times, but once again, in order to name a plane, you need 3 non-collinear points. And again, the only time you will ever name a plane with a single letter is if the assessment asks you to design a construction where the plane just has 1 letter. That's going to be the only time you ever do this. So break yourself of the habit of thinking you can name anything with a single letter. You can't. You're not allowed to unless the test tells you you can specifically. In order to name the plane, you need 3 letters. Now, which 3 letters? Let's discuss that. If I chose K, G, and L, that would not work. I could not choose those letters and name the plane. Because in order to name plane X, they cannot all 3 be on the same line. I can pick K, G, J. That one is perfectly fine. That one is perfectly fine. KGJ. Then what's another option? Could I do KGH? Yes, I could. Those are 3 points that are not on the same line. So we could do KGH. Could I do HGJ? No. I could not do HGJ because HGJ are all 3 points on the same line. And again, if you want to use all 3 points to name the line, you can't do it. 2 points to name a line. HGL to name the plane, that'd be all right too. Because I'm naming 3 points that are all within the plane, but they are not on the same line. So that's what we're going with. All right, what is another name for line GL? I'm pretty sure y'all are detecting a pattern by now. So I've got line GL. That's this line here. GL is going up and down. So line GL, what is another name for that? You could go and be lazy and say line LG. Technically you're correct. But as I mentioned during one of the other review sessions, if you have the opportunity to use another point to refer to the same object, do that. Because it shows that you understand the concept that any of these 2 points along this line can be used to name the line. So, line GL, another name for it, like I said, perfectly legitimate is LG. But what you should do is incorporate K in some way. If you incorporate K and say KG, then you're basically telling the people who are grading the assessment, I understand that in order to name this line, I just need to pick 2 points that are on that line. And I can pick any 2 points that I want. I'm not just going to go for the easy LG line name, line definition. So in this case, I'm going to go with KG. You have other options. You could do GK, you could do LK. Like I said, if you're going for this to get 100% with the assessment, I would incorporate K in some way. Just to show that, again, this line has 3 points on it. You can use any 2 of those 3. I'm choosing to use the third that was not presented in the problem to show that I understand I can name this line using any of these points. All right, number 5. What is another name for line HG? All right, I've got line HG here, so it is this whole line going from here all the way down to here. Now, again, could I say line GH? I absolutely could. That would be a correct answer. However, if you want to demonstrate that you are double E knowledgeable, you're not just secure, if you want to show that you're double E knowledgeable about the principles that you're talking about, and you understand that if you have a line, any 2 points on this line can be used to name it, you're not just going to use HG. You're going to incorporate J in there somehow. So in my case, I am going to say JG. Just throw that in, just use that. And I'm using that for the exact same reasons that I named KG in the previous problem. Because even though I have I've got 3 points on this line, and I'm asked to find another name for GH, I could just say HG, and it's perfectly fine. But I want to show everybody that's reading this paper that I can use J as part of the naming process too. I can pick J as one of my 2 points to name a line. Only 2 points to name a line. I know that I can incorporate J into the name and show that I have that understanding. In doing so, I would show that if I wrote JGH to name the line, that would be incorrect. 2 points, not 3, 2. Can I just name it J? Could I just say it's line J? No. If you're going to start with line J, that's perfectly fine, so long as you include one of these other points with it, GJ. Because again, 2 points make a line. All right. What is the intersection of lines A and B? So again, we're referring to line A and line B. When we're dealing with intersections, if a line intersects anything, it intersects it at a single point. What if a line intersects a plane? Point. What if a line intersects another line? Point. What if a line intersects a point? Well, that's the point. It's there at that point. It's obviously intersecting that point. So, when we're looking at 2 lines intersecting one another, we are looking for a single point. So line A goes all the way down here, line B starts here, goes all the way up. I think I spotted it. So because I'm referring to a point, all I need to do is write the capital letter for the point. I say that as though that needs to be reviewed. Everyone's been pretty good on labeling, especially with lines, planes, and points. But a little bit of review never hurts. Okay, number 7, name 3 collinear points. Collinear means that all 3 points are on the same line. Collinear, one more time, means that they are all 3, because we're asking for 3, so all 3 of these points have to be on the same line. They have to be on the same connected line from beginning to end. So I've got 2 options that I see. I can either list KG and L, because those are 3 collinear lines. They are all on line A. Or I can choose HGJ. Those are 3 points that are all collinear on line B. Think of it this way. If you can list the points in order and say, these points are on line such and such, and point to the line, then you know they're collinear. I say that points KG and L are collinear on line A. Line A, KG, L, there we go. Those are 3 collinear points, so that's what I'm going to write down. All right, 3. Last one, number 8. 3 non-collinear points. Well, if collinear means that all 3 of them have to be on the same line, that means that all 3 of them are not on the same line. Now again, I'm not going to try to make this more complicated than it needs to be. Linear, collinear, collinear, this is basically a term of comparison. When you make a list and you're saying that these points are collinear, you are saying that all 3 of those points are on the same line. By the same token, if you make a list of 3 points and you say these are non-collinear, then you are saying that all 3 of them are not on the same line. So in that case, I can pick any 2 points I want, as long as the third one is not on the same line that the first 2 are on. So let's do some examples. So I'm going to work with line A, and I'm going to say line K and G. line K and G. Those are going to be my first 2 points. I'm just going to go ahead and write these down here. Now, if I pick point L, first of all, we know from the previous answer that they are collinear. All 3 of them are on the same line. So I can't pick L, because if I pick L, all 3 of these points are on the same line. In order to be non-collinear, all 3 points cannot be on the same line. So all I have to do is pick a point that is not on that line. If you said B, you are wrong. B is not a point. If you said X, you are wrong. X is not a point. I went over this earlier. The only points that you can point to here are going to be J or H. Because let's say I pick J, and that's going to be what I actually do pick. Let's walk through and let's see if I can say that points K, G, and J are all on the same line. So K is on the line, G is on the same line as K, J is not on line A. So those are 3 points that are not collinear, as in those are 3 points that are not all on the same line. And that's all the definition is asking for. If it's asking for collinear, it means that you can point to a line and say this line has these 3 points. That's what it means to be collinear. If you're asked to provide 3 points that are not collinear, then all you have to do is say this point is on the, you do the same thing. You say these points are on this line and this point is on a different line. Maybe there's a drawing where there are 3 lines and 3 points on each line, and you have 3 lines and you have a point on each line. Each of those are non-collinear. So let me show you what that would look like. Forgive the smallness of the diagram here. And which ones haven't I used? L, M, N. If I said that points L, M, and N were non-collinear, I would be 100% correct. Because L is not on the same line as M, L is not on the same line as N, and M is not on the same line as N. So again, it's a term of comparison. Can I look at these points and say that they are all on the same line? No. K, G, same line. We're doing pretty well. J, not on the same line. So those 3 points are going to be non-collinear, which means, again, those are going to be 3 points that are not on the same line. And as long as you work with that definition, where it is, we'll be in good shape. All right, next construction is going to be for lines, questions 9 through 16. This should be familiar. All right, like I said, should look pretty familiar. We are assuming, according to the instructions, that all of these are going to be line segments. That's an important distinction for noting what each of these things are, because now, anytime we're going to be drawing something up, we know it is going to be a line segment. So keep that in mind, because if you get a question that says, what is a line segment, and you draw a line, that's a wrong answer. And we're going to have to write it off as a wrong answer. So we know this drawing is nothing but line segments, so all we're going to produce are line segments for the answer. Okay, name 2 parallel segments. Well, since we're working with the cube, we know that the cube has those magical properties, where every single side is parallel to its opposite, and every single intersection happens at 90 degrees. So this is a pretty straightforward example. I'm going to pick A, B, and C, D. Oops. You don't have to use this parallel notation, it's just something that I'm using in order to keep track of things. All right, so again, when you're working with a cube, when you're working with a drawing, when you're working with anything, you must have 2 points in order to name a line. If I were to, for example, say I need 2 parallel lines, I'm going to pick line A and line C. No, you can't do that. Because again, you as a student are not allowed to use the, well, I'll put it to you this way. If you can write cursive, you can use cursive, but I'm pretty sure none of you can write cursive. So when you're naming line segments or lines, you have to use 2 points. The only time that you don't have to is if the construction specifically asks for something. If the construction specifically says, draw line A such and such, then you just draw line A and you label it, and that's the end of it. For every other instance, so basically, anytime you're doing a construction and you're asked to label a line segment or label a line, you will use 2 points. The only time you don't is when the test specifically instructs you not to, or it instructs you to do something different. Put it in your mind, file it away, just burn it in, whatever you gotta do. Anytime you're naming a line, 2 points. Anytime you're naming a plane, 3 points. There's no shortcutting it. Every line has to be 2 points. You all sensed a pattern on what the wrong answers were yet so far? All right. Name 2 segments that intersect at a perpendicular angle. So again, I'm naming 2 segments. So even though they're line segments, I still need 2 points per segment. So I'm just going to pick DH. So DH is this front edge right here. And because of the miraculous properties of the cube, I know that DH intersects GH at 90 degrees, and I know that it intersects FH at 90 degrees. So I'm just going to pick GH just for the heck of it. So again, DH perpendicular to GH. And there is no doubt of what line segments I'm referring to, because I have named the line segments the 2 points that make up the line segment. Line segments, lines, rays, 2 points. You must have 2 points. Okay, what is the intersection of DH and ADC? All right, you have an intersection of a line and a plane. The intersection of a line will always happen at a point. Doesn't matter what it is intersecting. The line will intersect at a point. So we just need to figure out where the line segment is and where the plane is. And it will be, and where they meet, that point is their point of intersection. So I'm looking at, there we are, DH, so it's this front edge here again, and plane ABC, so it's the top surface. So DH intersects the top surface at point D. So that's the answer. That's all you have to put because, again, a line intersects a plane at 1 point. A plane intersects a plane and makes a line at 2 points. So the plane intersects the plane at a line, 2 points. A line intersects anything, 1 point. So again, line, anything, 1 point. 2 planes, 2 points. We'll get to another example where we get into this. Name the intersection of DHF and GEH. Alrighty. So DHF is this side here, this front-facing side here, and GEH is the bottom surface of the cube. And you pick that up just by looking at the line, just by looking at the lines, looking at the numbers, that whole thing. So name the intersection of the bottom face and the side face. That's going to be this line here, FH. And I used FH to indicate this because I have two planes intersecting. I have the side plane, bottom plane, they're intersecting to form a line. They intersect to form a line has to be 2 points. They have to intersect at 2 points. Planes will not intersect at a single point. They can't do it, it's got to be 2. All right, number 13, name 2 planes that are directly connected to AB. This is a little bit more of an abstract puzzle because normally we get 2 planes and we're asked to find their intersection. All right. With this one, we are given the intersection and we're asked to find 2 planes. Here's an easy way to do that one. Because we know it's an intersection of 2 planes, because we're given a line, 2 planes that are directly connected to AB. If 2 planes are directly connected to a line, it means that that line is their intersection. So I know, for example, that both of those planes are going to have AB as part of their names. So it's going to be AB. So at this point, I just have to figure out what 2 planes intersect where AB is in the middle of them. So the first one I can see very clearly is ABC. That's going to be the top part of the cube. And then AB is this far edge up top. And so it is also going to intersect with the far back edge that's not facing us at all. So that one's going to be ABF. So again, what I'm doing, if I know the intersection of 2 planes, that means that I know 2 of the points that are on each plane. Because anytime you have an intersection of 2 planes, whatever points are on that intersection are on both planes. Taking advantage of that, I know that both of these planes are going to have AB as part of their name. So I just need a third point to show that it's this plane and this plane. So I just chose ABC and then ABF. That's the answer. Let's see, name a line segment that intersects plane FGH at point E and forms a perpendicular angle. Well, that last part's a little bit of an unnecessary detail because any intersection with a cube is going to be perpendicular 90 degrees. But let's take a look. FGH, that's going to be the base of the cube. Let's see, and it has to intersect at point E. So it's the bottom cube and it intersects at point E. Name a line segment that intersects and forms a perpendicular angle. Way I see it, I got 3 options. I'm going to go with the option that I would personally recommend as an answer, and I'm going to say AE. AE is the easiest one, and it's the one guaranteed to get you all the right points. Because could I choose EF? Absolutely I could, because EF is a line segment that intersects this plane at point E. The reason I'm not going to choose EF is because it is part of the line segment. The same reason I'm not going to choose GE. As a matter of fact, EF, don't even consider it an answer. Because it's part of the plane, take back what I said. Because EF is part of the plane, it cannot intersect with the plane. GE cannot be part of the answer because it does not intersect with the plane. The only correct answer, was my first instinct, is going to be AE, because line segment AE intersects the plane, which is the bottom surface here, at exactly 1 point, which is E. So again, can't choose EF, it's part of the plane, you can't intersect if you're part of the plane. GE, same reason, but AE only intersects it at 1 point, which is the definition of an intersection. So That is why it is the correct answer. Name a plane parallel to DBC. I have hammered this home so many times. Thankfully, the handful of times it's come up with the assignments and with the tests, you all have delivered for me. Anytime you're asked to find two parallel planes, DBC is the top part. If you want to find two guaranteed parallel planes, you're going to use the top and you're going to use the bottom of the object. So DBC is the one, so we have to find something parallel to DBC. Because it's the top, I'm just going to use the bottom, EFH. So those would be some of the correct answers for the lesson with these drawings. The big thing to take away from before we go into the constructions, 2 points make a line. You need 2 points to make a line. All right, last part of the lesson is going to be constructions. I cannot put into words how proud I am of most of the class because these constructions, with a handful of exceptions, are top-notch. Every single time you all have an assessment that incorporates constructions, you deliver consistently, and it definitely elevates your grades. That said, there's some common mistakes that I keep seeing with some of these constructions. Draw a line M intersecting plane ABE. All right. At point X. This is the only way you can draw that sort of a relationship. If you want to move line M around, that's fine. If you want to put line M at a different angle, that's fine too. But if you are told that you need to draw a line and it intersects with a plane, you must do 3 dimensions. It has to go to a single point, it has to intersect at that single point, and then continue through the other side of the plane. When something intersects, that means that it intersects at one point if you've got a line. And this is, as I mentioned earlier, the only time you will ever name a line just a single letter. And it's because the assessment, or in this case the lesson, prompts you to. Otherwise, you come up with 2 points somewhere, but you give that line a name using 2 points. So anytime you're asked to draw a line that intersects a plane, 3-dimensional is not an option anymore. You must draw 3 dimensions. You must also label the point of intersection somehow. If it just says that the line intersects the plane but it doesn't give you a point, you know what? Give it a point. Because you have to know that the line intersects the plane at a point. That is the only way that you can do that kind of a drawing correctly now, especially moving forward into 1.3. All right. Okay, draw the intersection of planes ABC and XYZ. So this one's a little bit more complicated because normally when the question prompts you to draw 2 intersecting planes, you at least have something in common, right? Not really this time. So there you go. So I've got 2 planes, plane ABC, and I've got plane XYZ. There we go. 2 planes intersecting one another. And wouldn't you know it, the 2 planes that are intersecting one another are intersecting and forming a line ZC. This isn't part of the question. The question only asked you to draw 2 planes intersecting. So I've got one plane, very clear to see. I've got a second plane, equally clear to see. You have to, if you're asked to draw 2 planes, I have to be able to see 2 planes. I have to be able to look at them and see, yes, that is one plane, yes, that is another one. And if two planes are intersecting, then that means that they just have a shared side. That's all it means. Now, when it comes to putting your points out, when it comes to putting your points wherever you want to put them, I'm going to show you another way to make this problem very, very easy. Now, this is just two planes intersecting, but I haven't named them. I don't know which one is ABC, I don't know which one is XYZ. Remember, if you're going to draw something, you have to name it, you have to label it, otherwise it's going to be points off. So, because I just know that they intersect, that's all the question gives me, is that I've got two intersecting planes, but I don't know anything about their point of intersection. That means that I am free to put those points, to name those planes anywhere I want. I don't have to worry about putting them somewhere and having them need to be a part of the intersection. Because when we're naming planes, what do we need? We need three non-collinear points that are on the plane. Plane ABC is intersecting plane XYZ. Now, if I had two planes that had any digit in common, that had any point in common, I could not do this. If they had a point in common, I would have to put that point somewhere on the intersection. So, one last example, one last variation. Let's say that instead of ABC and XYZ, I have to intersect two planes, ABC and CDE. In this case, I can't put A, B, C, C, D, E. No. That is minus full credit. You absolutely cannot do that now. I remember back in the halcyon days of the first week of classes, I'd let you get away with that because we're just learning how to do constructions. But you guys are looking at like a double E rating on your exams. You got to represent, you got to show that you understand that this is not going to fly. If I have two planes and they have got a point in common, I know that that point has to be one of these two. If two planes that intersect have a point in common, that point has to be on the intersection. Has to. Cannot get around it. It has to be around, because in order for this point to exist on two planes, it has to be at their intersection. You can't have a point C up here and then a different point C down here. That's not how we're doing constructions anymore. You can only have one of each letter moving forward. So I imagine I've beaten this one into the ground sufficiently. So let's move on to the last one. Draw a line segment, and ray AB. Again, most folks got this, but I just want to make sure that I want to review it so that folks don't lose it. So we're going to start with line AB. That's line AB. Line segment AB. Okay. And ray AB. That's all we need. Now, because it was written as ray AB, I know that the A has to be the starting of it, and the B has to be where the arrow is. You can't make it ray BA. That's not what the arrow is. Because if we actually draw out what these are, this is a line that has points A and B on it that go on forever. This is a line segment that has points A and B that define it. These points A and B are how long you know the line is, A and B here. And then, like I mentioned, ray AB has to be drawn, oops, ray AB has to be drawn with the first letter at the line segment part, and then the second letter at the line part. So most folks really haven't had that big of an issue with it, but it is enough of a discrepancy that if at 1.3 you made a mistake like this, knocks you down immediately. You need to be able to understand the difference between a line segment, and array. Last one. Make a construct using every vocabulary word we've gone over so far with labels. The drawing must be readable. Last part's really more of a general statement. Last part's really just more of a general statement. Most of the drawings are in pretty good shape. Some are difficult to interpret. It takes a little bit of work for me to figure out what it is you all are doing. We cannot do that. I have to be able to look at the drawing and immediately see what it is you're talking about. So let's take a look at our vocabulary words. I know that skew is going to be one of them, so I'm just going to start with a drawing of a cube. I'm not going to label any of the points just yet. Oh, what the heck, I may as well. So, what I've got here, I've got plane ABC. I've got point A. I have got line AB. I have perpendicular intersection. Perpendicular intersection. AB is perpendicular to BD. And because it's a cube, I know I've got parallel lines. So I'm going to do this. Because it's a cube, I know I've got parallel lines. So AC is going to be parallel to BD. All just from one quick cube drawing. We're doing pretty well. Now the whole reason I drew it as a three-dimensional drawing just to start out with was I knew I was going to have to find some way to draw skew. So I'm going to draw two lines. And so I'm going to draw two lines. Actually, one of them is going to be a ray. So I'm going to draw a line and a ray, and they are going to be skew to one another, which means they do not intersect, and they are on two completely different planes. So I will call you X, Y. I will call you E, F. Because I drew a line, I must name that line. And in order to name the line, I'm going to use 2 points. EF is going to be the line. Now, XY is going to be my ray, which is another vocabulary word. However, if you notice the way that the ray is constructed, one part has a definite beginning and a definite end, and then the other part goes off into infinity, but there is a second point on there, which means I can turn ray XY into line segment XY. Alright, so I've got parallel point. At this point, I really just need some intersections. So what I'm going to do, I'm going to give one of these corners another point. So I've got EF, I'm going to say G. The reason I did that is because in terms of intersections, I have to show that a line intersects with a plane a plane intersects, a line intersects with a plane, a line intersects with a line, and then two planes intersect with one another. So all I have to do is point G down there, and I can actually get all three of those right now. Let's start with a line intersecting line. DG intersects BD. Yeah. Now technically, when you have perpendicular, that also counts as an intersection, but I just wanted to show, but I knew I was going to put the G down there anyway, so I wanted to hold off on it. So I've got line GD intersecting line BD. Now I'm going to have line GD intersect the plane. So ABD, okay. I just went ahead and wrote at what point these two lines intersect at one another. So now I'm going to say line DG that intersects plane ABC. That is also going to intersect at D. So now all I need to do is come up with two planes and a point of and a line of intersection that is defined by 2 points. Line is defined by 2 points. I actually can do that right now. I'm going to say line plane ACB and I'm going to say line ACB intersects at plane ACB intersects at plane BDG. So all I've said is that the top surface of the cube and the side of the cube intersect, which they absolutely do. But where do they intersect? They intersect at line 2 points, DB. All right, so let's run through our vocabulary words, make sure that we haven't forgotten anything. Plane ABC, got that. I've got point A, we've got points everywhere, don't have to worry about that. Line AB, we've got also plenty of lines, we don't have to worry about that. We have AB perpendicular to BD, nailed it. We have AC parallel to BD, nailed that. We have ray XY along the side plane here of the cube. I've got line segment XY, which is also part of the ray, but hey, you know, that's fine. It's line segment and ray. We can both work with that. I've got line, now we start going into the intersections. I've got DG intersecting with BD at point D, because again, two lines intersecting will only intersect at one point. A line intersecting anything will only be at a single point. So line DG intersecting line BD intersects at D. Now I have a line intersecting a plane. It will only ever intersect at a point because it is a line. DG intersecting plane ABC at point D, again, only at a point because it is a line. Now I've got intersecting planes ABC or ACB intersecting BDG. So I've got the top surface of the plane, and I've got the side of the top surface of the cube, and I've got the side of the cube. They are intersecting at line DB. And I realized, as I was looking at this drawing, the whole reason that I started out the drawing exactly the way that I did was because I wanted skew lines. And I had them, I just forgot to list them. So I'll just say, there we go. Finally, we've got skew lines. We've got skew XY as the ray. We've got line EF. They are on different planes. They will never intersect. That is skew. That is all of the vocabulary words that we have to do, and it is a relatively simple drawing if you choose to remember this kind of a drawing for whatever assessment may show up. So anyway, this was lesson 1.7. It was a focused review of many of the problems that came up in the last test, and many of the issues with some of the homework that's been turned in, or not homework, some of the assignments that have been turned in. It's also kind of a breaking into the idea of what 1.3 is going to have. We're going to have the 1.3 review on Thursday. As I record this, like I said, it's Tuesday, so keep an eye out for that video also. But if you really want to know how to improve from exam 1.2, this is the video that you want to watch.